Today we're going to play the virus game, which will help us simulate the logistic function. In this game, I have 40 numbers, each of which represents a person in a population. The first thing I'm going to do is generate a random integer on my calculator using the random int function that is found in the probability menu. Using a calculator page or your scratch pad, you're going to go to Menu, Number 5, Probability, Number 4, Random, Number 2, Random int, and type in 1, 40. This first person, number 9, is the first person to be infected with the deadly virus, and they get crossed out. Their number's crossed out. Then so that's day 1, one person is infected. On day 2, this person is still infected, and they encounter a second person, so person number 7 is also infected, and they get crossed off the list. On day 3, since we have 2 people infected, we have 2 potential more people that can be infected, so each of them encounter one other person, and 2 more people are crossed off the list. On day 3, now we have 4 people infected, so I'm going to generate 4 numbers. 1, 2, 3, 4. Notice that this person did not infect a new person. This person's already been infected, and so we would only have 7. Now, this is not the same example that's showing because I already did this a different time and got different numbers. But once I have 7 infected, then to be more efficient, I'm going to generate 7 numbers at the same time by doing random int 147, and then I check to see how many more numbers I can cross off my list. So when I did this before, this is what happened. Each day I counted the total number of sick people. Notice at first they were doubling each day, but then when we get to this day, I have enough people sick now that some people that were encountered by my 8 sick people were already sick, so only 6 new people were infected. Then I had 14 people sick, but on the next day only 7 new people were infected. And I kept generating numbers till at the end I had infected all 40 people. Or all 40 people were infected. I don't know if I'm the one that infected them. I then put these values in a list and spreadsheet on my calculator, made a scatter plot, and did a regression. In this case, I did a logistic regression, which is the one where d equals 0. And you'll see it fits the data very well. It has kind of a crazy looking equation. Looks like this. And I wanted you to notice a couple things about this equation. If I put a very large number in for x, since this is a negative exponent, e to a very large negative exponent is a decreasing exponential function, and the larger x gets, the closer that function gets to 0. So when x is extremely large, this whole value becomes 0, and I just end up with 40.3086 over 1, or 40.3086. So the larger x gets, the closer y gets to 40.3086, which becomes my upper bound, or a horizontal asymptote. The graph never gets bigger than this number. Now as x goes in the negative direction, and we're stopping here at y equals 0, there is a y-intercept. It's very small. I think it's like 0.3 if you put 0 in for x. But now I'm going to put in a very large negative number. If x is negative and this number in front, this coefficient, is also negative, then that means e is being raised to a very large positive exponent, and it gets extremely big. So the numerator becomes a very big number, and 40 divided by a very, very big number gets close to 0. So y equals 0 marks the lower bound. The function cannot go below 0. And this is what the graph looks like. This actually models our situation quite well, because at the beginning, with only a few people infected, the disease spreads slowly. As we get closer to about half the population infected, there are a lot of people infected and a lot of people still that were uninfected, so the disease spreads very rapidly at this phase. Then at the end, most of the people are already infected, so the rate of growth slows down, and at the end, with everyone infected, the disease won't grow any further. This situation works really well for a situation that looks very exponential to start with, and you notice our values 1, 1, 2, 8, 3, 4, 4, 8 are exponential. The values multiplying times 2 each time is doubling. But then there's some sort of upper limit, so it doesn't continue to grow exponentially. It begins to level off. So that is the logistic function.